The next several slides show how the passive methods of energy efficiency, known for ages, actually from the very first examples of human built shelters, had their impact upon forming the traditional residential buildings. They didn't have such impact upon public buildings because public buildings had another purpose. They demonstrate to which culture and to which religion the society is, and also they demonstrate technological and economical development of the society. While the leading factor in forming residential buildings, in designing residential buildings, is the comfort of their habitats. So, the main methods of passive energy efficiency are the form factor, which is the ratio between the surrounding of the building, the surrounding surface, and the volume inside that is heated. Zoning, which means placing the rooms for the basic functions and additional rooms according to better orientation, and also forming zones that serve as thermal buffers. The third method is the thermal capacity of the materials, their capability to absorb solar electromagnetic energy and to keep the generated heat inside. And the fourth one is volumetrical design for maximizing or minimizing the heat loss and for empowering or lessening the natural ventilation. As a short introduction, there are 7 climate zones on the Earth. The polar zone, which has very long periods of low temperatures and even periods without solar radiation and prevailing strong winds. The subpolar zone, which can be divided in forest subpolar zone and plain subpolar zone, where there also is a long period of low temperatures and a long period of low solar radiation and prevailing winds. And then comes the moderate climate zone with periods of low and also periods of high temperatures, periods of low and periods of high solar radiation, periods of raining and periods of dry climate, and periods where there are strong winds and periods when no winds happen. The next ones are subtropical and tropical climate zones. They have long periods of high solar radiation and high temperatures, and they also have periods of very massive rainings and strong winds and high humidity. And the next two that can be combined, these are subequatorial and equatorial climate zones with constant high solar radiation and high temperatures and everyday massive rains and very high air humidity. The reason of that diversity of climates, the reasons are two. The first one is that the Earth axis is inclined uh, towards the plane in which the Earth circles around the Sun. And the next one is that actually Earth circles around the Sun in an ellipse, not in a clear circle. And the Sun is not exactly in the center of that ellipse. It's little moved aside. Um, it's very small difference between the two radiuses. Sorry. However, it has big impact upon the Earth climates. And so, in all the climate zones, people learned how to survive and live there. So, each one of that climate zones had its strong impact upon traditional building design, residential building. So, in polar climate zone, the main task for a residential building is to keep the warmth comfort, to keep the warmth inside the building. So the applied methods are form, optimal form. So it reduces as much as possible the coolings from the strong winds, and it's very close to the ground, again to reduce the heat loss because of strong winds. Um, to have long corridor separated several times by some curtains to prevent the outside atmospheric conditions to have any contact with the interior of the main room, and to prevent the warm air from the main room to quickly go outside. And the third important moment is that the places where people sit and sleep are higher from the place the fire is built. The two examples given are a traditional house made by the locals that live in North America, in Alaska, and the right example is a traditional house made by the locals lived in the northern parts, in the polar parts of Eurasia. And the experience of those two traditional residential buildings is also used in contemporary polar stations to have a form that reduces heat loss because of the strong winds to be very close to the ground and to have form a central geometrical form. The next climate zone is the subpolar climate zone, and it has two main areas with different characteristics. The one is the woods, so-called taiga. It's mainly of tall vegetation. Again, the main task for the residential buildings is to keep the warmth comfort, to keep the warmth inside. But here people have more timber to build their houses. And there is kind of summer for about a month and a half. So the passive methods used in buildings in that climate zones are clear volumetric design, natural local building material, timber, which has high isolation properties. Many of that buildings are built with double walls, which has an air gap between them. They have doubled doors and a space about 50 up to 60 centimeters between the outer door and the inner door. So whoever comes in or goes out to have the possibility to close the one door and then open the other, for the same reason as the previous example, to prevent the cold wind from outside to enter the main room and to prevent the warm air from inside to get out. And they all have a very steep roof to prevent the gathering of too much snow, because snow is heavy and tends to destroy the roof construction. The examples given are an Indian wooden cabin from Alaska, a Russian cabin, cabin from Norway. This is picture of traditional house in Fanzhe province, which is in east northern China. And this is a traditional residential building, traditional house from northern Japan, northern Japan, the mountain areas. And they all have much common between them, although some of them definitely couldn't be copied from others. The steep roof, the timber material, many of them have a door on the second floor, because here there is another door, because the snow gets 2 up to 3 meters high in winter, and it's easier to exit the house from the second floor than to dig a very deep tunnel inside that thick snow mass. Uh, Almost all of them have um, hay, dry grass on the roof as an additional thermal insulation, small window openings. Only the first example has wooden covering of the roof. And that double door that unfortunately is not clearly seen. The next subpolar area is where the plains are, so-called tundra. Again, the main purpose of the residential buildings is to keep the warmth inside. They use again a circle form to lessen the heat loss because of strong winds. The examples given are the called yurta residential building of the moving locals in Asia, and archive picture of an Indian wigwam from Northern America. They have these circle forms, and also the walls are built in several layers from animal materials such as leather and some textile from animal wool. And the purpose of that layered walls is to keep actually some air between the different layers, since the air is the real insulation material. It's the material that prevents the heat exchange between the building and the atmosphere around. And in both kind of houses, the air is built at the exact, the fire is built at the exact center of the building, so its heat can be distributed evenly to all parts of the room. The next climate zone is probably the most expansed, and it has the most different subclimate zones. So it's not impossible to regard here to study all different variations of the climates in moderate climate zone, but presented here are 4 examples of residential buildings in let's say in 2 different continents and in 4 different countries. So the main task for the residential buildings in moderate climate is to ensure and keep the warmth within when it's cold outside, and to keep cool inside when it's hot season. The applied passive methods are a little bit more diverse forms, more windows, still not too big, zoning, orientating the main rooms with the main functions towards better orientation, and the serving rooms towards not so good orientation, using materials with high thermal inertia. That means they have a long period of accumulating heat and long period of keeping it inside and radiating it to the atmosphere. And the examples are from mountain areas in Bulgaria, Italy, India, and Chinese. And actually, this is Italy, this is Chinese, this is India, and this is Bulgaria. So they have common incline of the roofs, common proportion of windows and sizes of windows. They have stone or brick coverings of the roofs. And of course, since using the slope to turn the better facade of the buildings towards the south orientation, and of course using some walls to prevent the soil to fall down. The next climate zone combined are subtropical and tropical climates. And here, the main task for the buildings, for the houses, is to prevent from overheating the rooms inside and people inside. Since in this